All right, new term right off the bat. Yesterday we had an altitude, vertice, perpendicular to the opposite side. Let me introduce to you the word median. Median. Median also starts at a You're killing me, Thomas. Thank you. Median starts at a vertice, not perpendicular like an altitude, but goes to the opposite side's midpoint. Medians go to midpoints. That's the saying I always remember. Medians go to midpoints. So again, yes, like an altitude, it starts at a vertice, but goes to the opposite side's midpoint. So look at my diagram up here. I'm telling you, AD is a median. Tell me a true fact then about my diagram. AD is a median. Therefore, this is true. Median starts at a vertice, goes to the opposite side's midpoint. What's true about my diagram then? Give me something that you know is true. Whew, one zip. Matt, got anything that's true?
BD is congruent to DC.
Good job. BD is now congruent to DC because D is a midpoint. Notice I am not putting a right angle up there. It is not an altitude. Medians only go to midpoints. They are not perpendicular. Okay, they are not perpendicular. All right, so how can we construct a median now? All right, we can grab your compass in a second. In a second, let's talk about our plan. I want you to do a median coming from point C, right? So before you guys do anything with your compass, here's what I need. What's that point again right here? What's that point again? That's the what? Midpoint of AB. So is there anything we've done in the past with constructions that can find the midpoint of a side or goes through the midpoint of a side? Anything we've done in the past? I think so. What construction can I use here to find the midpoint of AB? Take my compass, put it on one of the endpoints, and here we go. Open it up. More than half the length. Here we go. So put your compass point on A or B. Open it up more than half the length. We're drawing a half circle here, right? And I'm going to really test your knowledge here in a second. Yep, go ahead. And leave your compass open in the same. Go to the other endpoint. Make sure you have 2 points of intersection on these two arcs. 2 points of intersection. 1, 2. You can take your straight edge and line it up. Don't draw anything in yet. Because I'm really going to test your knowledge now. Don't draw anything in yet. You can line it up. Go ahead, line it up. Wait for everyone to get done with their arcs. Take your time. Okay, hey, everyone's got it lined up. It's me too. I draw this line in. Is that a median? No, it's definitely not going to come from C. Name it though. What is it though? If I draw this line in right here, true, not a median, but it is a what of AB? But more. Perpendicular bisector, right? If I draw this line in, that's a perpendicular bisector. I can use it though, because what am I trying to find of AB? Midpoint. So go ahead, line it up. You don't have to draw the line in, but at least mark the midpoint of AB. All right, so the perpendicular bisector will get you to the median. And now line up your straight edge with point C and the midpoint. And you've just constructed a median. So perpendicular bisector and median, same construction. Same construction. And if you want to mark both sides congruent, you can do that as well. Everyone all right on the construction? All right, I'm going to turn this over to you and your group now for a little game. I have 4 triangles here. Each one of them has line segment CD. I want you to give me the best name for line segment CD. Here are your 4 choices. It's the 4 choices we've talked about so far. Perpendicular bisector, which was day 1. Yesterday, angle bisectors and altitudes. And then we just went over today, medians. You give CD the best name you can based on the information I provided. You and your group, go ahead, go through all four. CD only. What is the name of CD? These are the four special lines we've talked about over the last 3 days now. Give CD a name. And then I'll call on 4 different people. But discuss it in your group too. Make sure we're all in agreement.
Wait, do they all have to be used?
I didn't say that. I said those are your choices.
Wait, so we could use one more.
I just said those were your choices.
Yeah.
I just said those were your choices. I didn't say how many should be used, how many times. It's just these are the 4 we've gone over the last 3 days. These are the 4 special lines in a triangle.
This one's definitely not median. The last one? Sure. That.
Ready? To go? Okay. Part A, what is CD? Part A, what is CD? Best name for CD? 1-5. Gabby, what'd you guys come up with? That is an altitude, correct. If you think AD is congruent to DB and called it a perpendicular bisector, you're just assuming that because it looks like it. All right, there's no proof there that AD and DB are congruent to make it a perpendicular bisector. How about CD on part B? What's our best name for that bad boy? 6, Thomas?
Median.
That is a median, what we just went over, right? Because D is a midpoint, and it's coming from a vertice. Part C, what are we calling that one? 9, Ian? That is an angle bisector, correct? And I love this one, part C or part D. What are we calling CD over here now? 1-5, Gabby, back to you. That's an altitude, right? And we talked yesterday, what type of triangle is CAB? Must be CAB. Here's my altitude. Must be obtuse, right? Because I always have an altitude on the outside. Good, everyone, good. Any questions about these 4? So yeah, I didn't need perpendicular bisector. You good, Matt? Yeah. Okay. Anybody else? All right, now let's keep talking about a median. I'm not done with a median yet. Go on a graph right now. Go ahead and graph triangle ABC, and then you got some work to do in your group. Once you have triangle ABC graphed in your group, find the midpoint of each side and draw on the median and see if we find out if anything special happens when you draw on the medians. All right, so once you have triangle ABC graphed, find the midpoint of each side and draw in the median for each side, all right? You have to use the midpoint formula to do so. No construction here, no construction. I want it done algebraically. I don't think you need the formula for the midpoint is CB, right? I think you guys can just figure that out by counting and cutting it in half. Does everyone have the, go ahead, finish up. And see if you notice anything. Maybe something we've noticed the last 2 days. Maybe toss a little vocabulary term at me here when I ask you this. What do you notice about all three medians in a triangle? What do you notice about all three medians? Maybe throw a little vocabulary term at me. If not, that's fine. Thomas, what do you notice about them?
Oh, they're congruent.
Congruent?
Or concurrent.
Concurrent. Yep. All right. Everyone see that? All right. So here we go. All three medians in a triangle are concurrent. I don't know if you guys are keeping tabs or not, but this is the fourth set of lines that are concurrent in a triangle. Perpendicular bisector, day one. Yesterday, angle bisector, altitudes, and now medians. All, as everyone seeing, all four of these bad boys are concurrent. Meaning I draw all three of them in a triangle, they're all going to hit at the same point. Perpendicular bisector, what's that point called? Circumcenter. Angle bisector, incenter. Altitudes, orthocenter. Medians, introducing, let it roll off your tongue. Centroid. Yeah, centroid. That is the point of concurrency for the medians in a triangle. Years ago, when this course wasn't so packed with all the material I have to get through before the Regents exam, the centroid, this is just like a cool fact. If you ever, I'm sure you'll try it on your own. If I had you guys cut out that triangle right now, ACB, and we had sharp pencils, real sharp, and you put your tip of your pencil on the centroid, it would balance perfectly. It's also called the center of gravity for a triangle. It would balance perfectly on your tip of your pencil.
Wait, what? Can you say that again?
Sure. It's a cool fact, that just not something you guys need. I'm not going to test you about, but if I had you guys cut out triangle ABC,
yeah,
okay, and let's say we had a sharp, really sharp pencil point. I take triangle ABC, I place the tip on the centroid, it will balance perfectly. It's called the center of gravity for a triangle. Okay? Not the center, just the center of gravity where it balances perfectly. Anybody but me find that great? Awesome. Okay, I didn't think so. All right. Now the fact I need you to know. All right. Now the fact I need you to know, other than the center of gravity here, that cool fact. Centroid. What's so great about it? Circumcenter. What was so great about it? Equidistant from the vertices. Incenter. Equidistant from the sides. Orthocenter. Nothing there, but make sure you know where it is. Centroid. No equidistant here, but splits the median. Splits a median into a ratio of 2 to 1. All right, I will describe what that means here in a second. If you haven't done so already, mark the centroid on your graph, please. Mark the centroid on your graph. Here's what I mean by it splits every median into a ratio of 2 to 1. Everyone, we'll make this easy. Look at the horizontal median right here, okay? The horizontal median. What is the distance? What is the length from the vertice to the centroid of that median? Vertice to centroid, how many units? 4. And what is the length of the centroid to the midpoint of the opposite side? 2. Everyone see what I mean by 2 to 1? Okay, 2 to 1. What is always the bigger piece? The bigger piece is always vertice to centroid. That is always the bigger piece. So for instance, if I put, from C to the centroid, if that's going to be, 20, the other piece would be 10. Okay, 2 to 1. Splits every median into a ratio of 2 to 1. We're all good? All right, let's practice it, and then you got your assignment. Okay, M's the centroid of triangle WOR. WM is 16. How about WX, the actual median, right? WX, the actual median. All right, so I know it splits a median up into a ratio of 2 to 1. I got that. What's MX before I answer the question then? For Doyle, what's going to be the length of MX? 8, right? 2 to 1. And the part that's always bigger is from the vertice to the centroid. That's the 2 part. So I'm not going to even ask anybody here. We can all add WX, 24. And part B now, YM is 12. How about YO and MO? If YM is 12, M's the centroid, breaks the median up in a ratio of 2 to 1. Let me start with MO. What do you think? Length of MO here? 3, 8, 24. Yep, you double it. And I won't ask anybody for YO. Hopefully we can all add 24 and 12. Get 36. And finally, number 5. All right, this is when I go off the rails a little bit here. You can read through. Medians AD, BE, and CF intersect at G. Whoa! I didn't come out with this. I didn't say it was this, but how much? What do you know point G is going to be here then? Medians. Medians AD, BE, and CF. Oh, G must be the what of the triangle? 5, Haley? Centroid. That's where I need you guys to be by the quiz on Tuesday. I may not come out and say centroid, in-center, circumcenter. But at least I told you these were medians. Oh, medians all intersect at the centroid. Now I'm thinking about 2 to 1. BG, 2x plus 10. GE, 3x minus 1. Let's see if we really understand this whole 2 to 1 concept. 2x plus 10 equals 3x minus 1. Completely incorrect. Do we understand that? Completely incorrect. I didn't say 1 to 1, 2 to 1. Somebody adjust it for me so it is correct. There's 2 ways you could adjust this to make it correct. But right now, don't even think about solving it. That beast is wrong. Correct it for me. 6, Thomas, correct it.
2x plus 10 equals 3x minus 1 plus 3x minus 1.
Okay, so you're multiplying. Yep, that's fine. You're multiplying that by 2. Or If you're really feeling nuts, I could multiply this by 1/2, yeah. If you're really feeling nuts. Not both, though. Just decide, multiply this 3x minus 1 times 2 or the other side times 1/2. And then remember, you're not looking for x here. We're looking for BE. Yes, I know x is 3. Yes, I know x is 3, but I'm looking for BE. So when you're ready, let me find BE when you're ready. Gianna, when you're ready. 24. Good work. And I know we are done with the notes, but I want to start the homework with you. So if you flip it over, the first thing on the homework tonight I'm asking is to review every concept we've done so far and put it into one chart for me. First thing, I should have deleted this before we copied it. I don't care about, you can write it a description about it. I'm more concerned with, can you draw it? Okay, so don't worry about description. I want to make sure you can draw it. So let me do the first row with you. So it's a perpendicular bisector. Can you draw me a picture of that? Start with a triangle, right? Because we're only doing these in triangles. Start with a triangle and just draw your best picture of a perpendicular bisector through a side. Just one side. Okay, so draw a perpendicular bisector with correct markings through one of the sides. We know we have 3 of them, but I only need 1 drawn. So I don't care how you do it. Everyone putting right angles there? Mine's not really drawn to scale, and hash marks, hopefully. That's a perpendicular bisector. Okay, hey, question. Let's see if we really know what's going on. Does it have to come from a vertice? No, that's the only one. Where do I still have my list here? That's the only one that does not have to come from a vertice. The other 3 have to come from a vertice, remember. All right, that's the only one that does not have to come from a vertice. All right, I do draw all 3 in. Where's it going to intersect? What's that point of concurrency called? That's called the, circumcenter, yep. And what's the special property? What's so great about the circumcenter? Equidistant from vertices. So this is giving you a little taste of everything you need to know here. Can you draw it? What's the point of concurrency? And what's so great about it? And I will leave you right with that now. Okay? I did put my version on the homework answer key if you want to take a look when you're done.